Hello students, this video is to help with the Applications of Linear Functions unit in Common Core Algebra 1. I'm giving a quiz in the next couple of days on the Applications of Linear Functions unit. It's on the first 4 lessons in that unit, and I wanted to go over the review sheet. So take a look at the review sheet that I handed out in class. The first problem talks about Naoya reading a book from cover to cover at a rate of 55 pages per hour. After reading for 4 hours, he had 330 pages left to read. So what we have to do is write a linear function and determine how many pages the book has and how long it will take for Naoya to be done with the book. Take a second to try to answer this question. So pause the video now, and then I'll give you the answers in a moment. So my first step was to annotate, and that's what I did. I underlined 55 pages per hour and reading for 4 hours and 330 pages left to read. The first thing I noticed is that rate and per both indicate to me that that is the slope, so this number is going to be our slope. We know that it's 55 pages per hour. I also know that the variable that it's talking about per, like per hour, that hour is going to indicate the input variable, or the x. So where I saw a number of hours, I labeled that as x, so I know that t and x are going to be the same. The other variable is number of pages in the book, which is p. I know that that's the other variable in the equation, so that's going to be my y. So again, per hour, I know that per indicates slope, and hour indicates the x variable, just like slope is usually multiplied, or always multiplied by the x variable. So that's my situation now. I have my annotations done. Now I'm going to try to take this information and put it into a linear function. All right, I ran into a little problem. Here's the problem. I know that my slope is negative 55, and if you're not sure why it's negative 55, think about it. What we're doing is we're starting a book from whatever number of pages it is, and we're reading it until there are no pages left. So we're going from a large number, 330 plus something, to a small number. That is a negative slope. It is decreasing in value. Anyway, we're given the slope, and we're given a couple of values here, our x value and our y value, but we're not given a place to start from, a number of pages that it started with. So that b, that y-intercept, is a mystery to us. So the first thing we're going to do in this problem is actually try to do section B. Once we're done with that, once we find our y-intercepts, we should be able to come back and answer section A. So again, for letter B, it asks how many pages does the book have? And we know that the starting point, how many pages does the book have to start with, is going to be our y-intercept. And we can see the work that we did here for y-intercepts. I know that the total number of pages in the book is equal to the pages that were already read plus the pages that are left. I know that I've read, or in this case Naoya has read, 55 pages per hour. And they've read for 4 hours. So that means 55 times 4 is the number of pages that they've already read. That 55 times 4 is going to give us 220. Then that 330 was the information given to us here, that there's 330 pages left to read. 220 plus 330 is going to be 550. This is our y-intercept. This is the number of pages that we started with. So now that we have our slope and our y-intercepts, we should be able to get the linear function written. So popping back up to the linear function, we know it's y equals mx plus b. The y value gets replaced with p because we've already established that y and p are interchangeable. The slope is not 55, but negative 55. We've identified that before. The x value is t, as we said before, and also the newly acquired y-intercept is 550. Now what we're going to do with this linear function is try to answer letter C. After how long will Naoya be done with the book? Now keep in mind, being done with the book means that there are no more pages left. So that means the number for p, which is the number of pages that are left, should be equal to 0. So I've taken the function, which is p equals negative 55t plus 550, and I've substituted 0 into that function. Now what I'm going to do is solve this function for t, because I'm looking for after how long, which is time. So you can see the algebra that went on here. The answer I got was t is equal to 11. But as I said in class, we're going to take this math answer and translate it back into the real world. So we need a quick sentence that describes what happened here. So we finish this off with this information. It says Naoya will be done with the book in 11 hours. And we're done. Let's take a look at the second question. On the first day of every month, you count the number of people in the subway platform between 9 and 10. You summarize your results in a table. So with this table, we're going to try to write a linear function that relates the number of people P to the number of months since January. Again, I'd like you to pause the video, try to take a look at this question, and then I'll give you the answers for it. All right, we did a little annotation here, and I'd like to walk you through it. We counted the number of people on the subway, and then the next word is each. Remember, each or per or every, this word is going to indicate where the x variable or the input variable is. The next thing that it's describing should be the each or the every or the x. So each morning. Oh, well, neither of these are mornings, but it's talking about each morning on the first day of every month. So the x variable is going to be mornings of the day of the month. In other words, x is months. And we could have guessed that because the first row in this table is months. So that months is going to give us our x. Whereas the other variable, y, that should be pretty straightforward. The y variable is going to be the people. We know that that's the variable that's changing on the bottom here, and it seems to be changing by the same amount every time. That's the constant slope that we spoke about in class. So now we have x as the months and y as the number of people. Now, I just said that the constant slope was 17. We went up by 17 every time. So that slope should be 17. The y-intercept is 21, and I know that because I started from January. Remember that since that we talked about in class? Since January talks about the starting value. So if I'm told since January it's been going up by that amount, that since is going to indicate our starting value. So now we have all the information we need in order to make our equation. We have our slope and our y-intercept. So I'll start out with y equals mx plus b, and I'll substitute everything else that I need. So this might be a little confusing because we're using m for slope here, and there's also an m, which is the number of months that corresponds to x. But keep in mind that this is the slope, which is 17, and x corresponds to the number of months. Now that I have my function, I'm going to use it to predict the number of people in August. So let's be careful here because in August doesn't mean 8, even though it seems like it should. The number of people in August is indicated by how many months it's been since January. So this is January, so it's been 0 months since January. February is 1 month since January. March is 2 months since January, and so on. So we know that April is the 4th month of the year, but it's been 3 months since January. That means August is the 8th month of the year, but it's been 7 months since January. I'm going to write that out because it's an important point. So now that I know that August is 7 months since January, even though it's the 8th month, I can take this information and substitute it in for m. That's what I'm going to do now. So you can see the thought process and the algebra behind this. I know that m is going to be 7, so 17 times 7 is 119. The 21, which is the y-intercept, is added to that 119 to give 140. And if you had followed this chart one more time, I would have simply added 17. So 123 plus 17, that's right, 140. So I needed to use the function to predict it, so I couldn't have just added 17. It's the same as saying use algebra to predict the number of people, or solve algebraically. We needed to show all our work. That's why we did this work. And remember, it's a real-world scenario, so we're going to write a sentence that summarizes it. So there you go. There's your sentence. Remember, we're predicting, so we won't say there are going to be 140 people. In August, there should be 140 people. That's what we should do in this case. Now it says use your function to predict how many people were waiting on the platform last December. Let's think about it. If January is where we're starting from, and the number of months since January is m, it looks like last December we're going backwards. So instead of using a positive number to represent this, we're going to use a negative number. We've gone backwards by 1 month. So last December is going to indicate 1 month before January, or -1. So if it's 1 month before January, we're going to use -1 to represent that change. So instead of using a positive value for m, we're going to use -1. Here's my work. So there it is. I know that -1 plugged into or substituted into this equation, this function, is going to give us 4 as our p-value, which means last December there were probably 4 people on the platform. Again, we're using probably because this is a prediction. Let's take a look at the next problem. Mariana tried to drink a slushie as fast as she could. I believe that's how you spell slushie. She drank it at a rate of 4.5 milliliters per second. After 17 seconds, 148.5 milliliters of slushie remained. So we're first going to try to write the linear function, then figure out after how long it'll be completely gone, and then finally try to share it equally with Trina. Pause the video, try it out, and I will give you the answers in a moment. So I did a little work for you here. I did some annotations. I looked at the variable, which is right after the per. That should be our x. I looked at the thing that was indicated as rate. That should be our m, our slope. And I was also taking a look at this information, and I realized that this didn't give me the y-intercept, so I had to figure it out. The total number of milliliters in the slushy is going to be 4.5 times 17. That's the rate times how much she's already drank, plus what's left over, similar to the book problem that we did in the beginning of the video. So that's 148.5. If I combine these two, I should get 225. That's her starting point. That's her y value, her y-intercept. And remember from the book example at the beginning of the video, you know that the slope here is going to be negative because we're decreasing the amount of slushy that is left. So that decreasing relationship needs a negative slope. We took the two parameters, the slope and the y-intercept, and we put them together into a equation, a linear function, and we got m equals negative 4.5t plus 225. Next, we're going to use that function to answer questions B and C. For letter B, we focused on the idea of completely gone. If it's completely gone, the slushy will have 0 milliliters left. So we took that 0 and we substituted it in for m. M became 0. Now we needed to solve the equation for t. So I took this negative 4.5t, I brought it to the left-hand side, made it a positive 4.5t, and then I divided both sides by 4.5. That means I isolated the t, and the 225 divided by 4.5 gave us 50. So now our answer, our solution, is here, but we need a sentence to summarize. So there's our answer. The slushy will be completely gone after 50 seconds. The next question asks us to figure out if she wants to share the slushy equally with her cousin Trina, after how long should she stop drinking the slushy? Now, there's a couple ways to go about this, but the easiest way to think about this is she wants to only drink half of the slushy because she wants to share the slushy equally. So if she only wants to drink half the slushy, she's only going to drink for half the time. So in other words, I'm going to take this 50 and cut it in half. That means she should stop drinking after 25 seconds. There's another way to do this problem also. We know the total is going to be 225. I want her to drink only half of that, so we need to figure out half of that 225 and then substitute it into our equation. And once I find out that equal point, that point where she should stop drinking and let her cousin drink, we take that and we substitute it into the equation, into the formula, or the function. 112.5 is the new m. So now we're going to solve this for t, just the same way we did with the previous problem. So you can see in order to solve for t, we subtracted 225 on both sides, and we got negative 112.5 on this side and negative 4.5t on this side. We divide both sides by negative 4.5t to get 25, which is what we predicted from before. She should stop drinking after 25 seconds in order to share the slushy equally. So that was two different ways of solving the same problem. Let's take a quick look at the last problem about the cab company that charges a $3 boarding rate in addition to its meter. I'm going to show the answer to this question, so pause the video first, try it, and then unpause it to see the answer. So my annotations are here, and hopefully it's pretty obvious that I need you to annotate on this quiz. The initial value, which is the y-intercept, that's 3. The slope or pattern is 2, and the mile is going to be my x variable. So I made my function, which is 2d plus 3. How far can you travel for $45? Here's what it looks like. So in this question, it gave us $45. That's our c. We substituted that value in for c and solved for d and got 21. So that means you can travel 21 miles for $45. We'll also try to answer this question after how long will the cab fee be $99. Here's the work. So using this information, we can solve for d and get 48. And it turns out you can travel 48 miles for $99. Last but not least, it wants us to graph the equation. Take a look at the graph, and that'll be the end of the video. So here you can see I scaled the graph by ones, 1, 2, 3, 4, 5, 6, etc. The x-axis has the number of miles, and the y has the number of dollars. And as you can also see, I plotted the points starting from the y-intercept, which is 3, and I went up 2 over 1 because of my slope, up 2 over 1, up 2 over 1. I sealed my graph by making a straight line, extending to the edge, but obviously not going to the negatives because you can't take a taxi in negative miles. I put an arrow, and I labeled. All right, students, that's the end of the video. Good luck studying.